real-time PCR, also known as quantitative or qPCR, determines the actual amount of PCR product present at a given cycle. By using a fluorescence report in the PCR reaction, this process allows you to measure DNA generation in the qPCR assay. In a probe-based qPCR reaction, you have your template, which contains the target sequence that you are interested in. You also need primers, dNTPs, and DNA polymerase of your choosing. In addition, you will need a probe labeled with both a reporter molecule and quencher molecule. Typically, probes are sold as separate, custom products because they are specific to the target sequence. Denaturation is the first step in the PCR reaction. The thermocycler heats up to roughly 95 degrees Celsius, which causes the double-stranded DNA helix to melt open into two single-stranded DNA templates. During the annealing step, the temperature cools between 45 to 65 degrees Celsius. Probes, labeled with both a reporter molecule and a quencher molecule, and sequence-specific primers, anneal to the single-stranded DNA template. During this cycle, DNA polymerase attaches to the prime template and begins to incorporate complementary nucleotides. Finally, during extension, the temperature slightly rises to 65 to 75 degrees Celsius. During this phase, DNA polymerase extends the sequence-specific primer with the incorporation of nucleotides that are complementary to the DNA template. The DNA polymerase then displaces the reporter molecule from the probe, resulting in fluorescence. The fluorescence accumulates as cycling of PCR continues and is measured at the end of each PCR cycle. The intensity of the fluorescence generated by the reporter molecule above background level, the CQ value, is measured and used to quantitate the amount of newly generated double-stranded DNA strands. After repeating the denaturation, annealing, and extension cycles approximately 35 to 40 times, you are ready to begin analysis. The CQ values can be used to quantitate starting amounts of DNA, establish a standard curve for gene expression studies, or other analysis. Probe-based qPCR is a great option for specific hybridization, no false positives, and amplification of two distinct sequences in one reaction tube. Instrument compatibility is critical for qPCR. Be sure to select the right product for your instrument. In addition, qPCR methods vary on levels of fidelity, speed, and convenience. We recommend using our PCR selection guide and our technical support team to select what products are right for you at sigmaaldrich.com/PCR.